Hello, my name is Zachary Davis. I'm a team manager at the Danish Technological Institute, and today we're showcasing and exhibiting at the E22 in Odense. So today we have actually quite a few demonstrators. We are working primarily with printed and flexible electronics, and how we can integrate electronics into objects that normally or typically can't be done. And a really good example is how to put electronics onto non-planar objects, and this is actually a drone wing that we have obtained, and we're able to, with a transfer process, a print and transfer process, to actually print conductive tracks and actually also glue onto LEDs. So you can see here, this is the red on the front, on the top of the wing, and then we turn it over, we have on the bottom side a white LED. So this is actually very interesting in order to be able to put electronics places and integrate them onto objects that typically can't be done with traditional technologies. Another one of our demonstrators is the smart textiles, or e-textiles. So this is an example of that, where we have actually printed and transferred some conductive wiring and mounted an LED and a resistor. So as you see here, we can put the 9-volt battery on it. It lights up quite nicely, and after we stretch it, it's still functioning, of course, with the nice LED. We have also performed extensive wash testing on this. We can actually put this into the washing machine and wash over 50 times without signs of degradation. And it's also water resistant. That means that we can actually put it into water and take it out, and it's still functioning while it's wet. So actually it's really good for perspiration, etc., etc. Quite a lot of work is done into this to make these types of demos. So this is a printed EMG sensor, or a wearable EMG sensor. So the idea is that we have printed both on the TPU substrate some silver and graphite electrodes, and then we have actually encapsulated them also in TPU to actually have a nice sort of fit on the skin. And then we laminated the whole thing into the sleeve. So the EMG sleeve is now on my arm, and it's a functioning prototype. So the EMG is constantly the electronics is constantly monitoring my muscle movements and sending it to my phone. So actually Precure has made an app, and if you look at the app, and if I start to move my hand, then you can see actually the fluctuations in the EMG signal. And if I really sort of flex my muscles, I can really get it to react quite a lot. And the idea with this app is to monitor the muscle and to make sure that I don't overexert my certain muscle groups. For example, if you have a tennis elbow or something like that. Yeah, so at Danish Technological Institute, one of our main goals and aims for our existence is to support industry with the uptake of new and emerging technologies. So what we are doing here is actually taking a look at how we can implement print electronic technologies into industry. So that means and the reasons why we're doing that is because it's lightweight, it's flexible, it's also more sustainable, and also cost effective compared to traditional PCBs, etc. In order to do this, we actually have quite a lot of facilities and expertise. We actually start all the way down to the materials. We can actually develop and produce raw materials. We can then formulate those materials into inks for different printing processes. We actually have quite a large variety of printing machines, inkjet and serigraphic printing. And then, of course, when we actually do make the components, we need to be able to validate and characterize them. So we have all these characterization facilities to do that. And of course, design of whatever we can also support in design of the components and the systems that we're doing. We have worked in quite a few different things. So electronic textiles is one of the more emerging areas we're looking into. Embedded sensors, how do we put sensors onto, for example, drone wings, or how do we embed them into composites? We can then also work into biocompatible sensors, having sensors on the skin. We have actually some demos on that. And last but not least, transparent electronics. We can actually make paneling that is fully transparent with touch and LED lighting capabilities. And then what can we use that for? So right now we're looking into several application areas, for example, activity tracking, aerospace, of course, smart construction, clothing, smart clothing, interior design, etc. So these are just some of the things that we can help these type of applications area with.